Planets and stars, you and I, everything you can see are made of what physicists call baryonic matter. But most of the matter in the universe seems to be of another type that we cannot see because it doesn't emit or reflect or absorb light, and so we call it dark matter. We still don't know what it is. Today I'm going to tell you the story of the OWU connection to its discovery. While we cannot see dark matter, it does have gravity. In the 1930s, astronomer Fritz Zwicky discovered that galaxies and clusters are moving fast enough that the clusters would fly apart if the gravity of the matter that we can see was all the gravity that was available. This was our first hint of the presence of unseen dark matter. This is a well-known photo of Fritz Zwicky that's said to capture his personality. One day I was staring at it, and I was thinking to myself, who does he remind me of? And then all of a sudden it hit me. Oh. One more time. One more. But this is not the OWU connection to the discovery of dark matter that I'm talking about today. This is Vera Rubin. And this is the Andromeda Galaxy. In 1970, Vera Rubin and Ken Ford published a well-known paper called Rotation of the Andromeda Nebula from a Spectroscopic Survey of Emission Regions. Now, emission regions are star-forming regions like the Orion Nebula seen here. They're bright enough that we can study them in other galaxies besides our own Milky Way, including in the Andromeda Galaxy. Now, a train piles up the sound waves in front of it because of its motion and stretches out the sound waves behind it. It's for this reason that a train whistle's pitch sounds higher when the train is moving towards you and lower when it's moving away from you. It's also the reason why a race car sounds something like this when it's approaching and then receding. Only one performance per day of that. It's also the reason why we can tell how fast things in space are moving, because these shifts in wavelength and frequency are called Doppler shifts, and they apply to light waves as well as sound waves. Vera Rubin and Kent Ford measured Doppler shifts of light of known wavelengths coming from hydrogen in emission regions orbiting the center of the Andromeda Galaxy. And they used that to determine how fast they were moving in their orbits versus how far away they were from the center. They were surprised to discover that beyond a certain radius, the orbital speeds of all of those emission regions were almost all the same, even very far from the nucleus of the galaxy. Now, in photographs, as you can see there, it looks like the mass is concentrated towards the center. If that were really the case, then we would expect the speeds of the emission regions to decrease as we got further from the center, just like what happens in our solar system, where more distant planets orbit the sun at slower speeds. Now, Vera Rubin, in subsequent years, measured many more galaxies, and the result was always the same: near constant orbital speeds, even very far from the center. Something had to be responsible for this. Something had to be causing this unexpected behavior. And that something is dark matter, which provides extra gravity that makes everything orbit faster than it would if it were not for its presence. We now know that dark matter is more than 5 times more abundant than the baryonic matter that you and I are made of in the universe. So in some sense, we're the extraordinary matter, and that's kind of the ordinary matter. So what is the OWU connection to the discovery of the dominant form of matter in the universe? Well, from their paper, I'll have to turn around to read it here, from their paper, the DTM image tube spectrograph was used on the 72-inch telescope of the Ohio State and Ohio Wesleyan universities at Lowell Observatory. Furthermore, for the Perkins telescope, the scale perpendicular to the dispersion is 40 arcseconds per millimeter. So in other words, they used the Perkins telescope at Lowell Observatory that was originally installed right here in Delaware at Ohio Wesleyan's own Perkins Observatory. And at the time they used it, it still belonged to Ohio Wesleyan. And so therefore, OWU! So if you'd like to know more about dark matter, take Astronomy 111, or major in astrophysics and take Astronomy 311. Thank you.